Yeah, it's officially the biggest midget in the game. I don't know. Make way for the insult.
As a third-year student of Sri Lanka Institute of Information Technology for the subject of Programming Language and Design Concept, we are asked to do an assignment based on simple narrow-down concept issues in programming language development. It's Maheshika, J.A.D. Wickramasuriya, Delpechitre, K.K.K. Chinthaka, K.R.J. Karadana. These are the participants who mainly designed in this video. As the PLDC assignment, we are focusing in the well-known object-oriented principle called polymorphism. Polymorphism occurs when a single function represented in different tasks. Two functions with the same name and the same parameters cannot have different return types. Compilers select the appropriate function by matching arguments to the parameters. Generally, the ability to appear in many forms in object-oriented programming. Polymorphism refers to programming language ability to process object difficulty.
Uses in Ruby. Now let's move on to examine polymorphism uses in Ruby. In the above example, there are two classes implemented called cat and dog. There is an attribute called name for each these two classes and it is initialized. Each and every object of the following classes should be identified whether it contains to which class and call in the method which he talk meow or of. Uses in Perl. Polymorphism in Perl is inherently straightforward to write because of the language's use of signals and references. This is the animal example in standard object-oriented Perl. The output of the program can be shown as at the end. This means that Perl can also apply polymorphism to the method call. Example below is written using the moves module to show modern object-oriented practices in Perl. Use of pointer to base class. Before getting into this section, it is recommended that you have a proper understanding of pointers and class inheritance. If any of the following statements seem strange to you, you should review the indicator sections. One of the key features of derived classes is that the point to a derived class is type compatible with the pointer to its base class. Polymorphism is the art of taking advantage of this simple but powerful and versatile feature that brings object-oriented methodologies to its full potential. We are going to start by rewriting our program about the rectangle and the triangle of the previous section, taking into consideration this pointer compatibility property. In function main, we create two pointers that point to object of class cPolygon, pPoly1 and pPoly2. Then we assign references to rect1 and prg1 to these pointers. And because both are objects of classes derived from cPolygon, both are valid assignment operations. The only limitation in using pPoly1 pointers to pPoly1 and pointer to pPoly2 instead of rect1 and prg1 is that both pointer to pPoly1 and pointer to pPoly2 are of type pointer to cPolygon, and therefore we can only use these pointers to refer to the members that C rectangle and C triangle inherit from cPolygon. For that reason, when we are called the area members at the end of the program, we have had to use directly the objects rect1 and prg1 instead of the pointers pPoly1 and pPoly2. In order to use area with the pointers to class cPolygon, this member should also have been declared in the class cPolygon and not only in its derived classes, but the problem is that C rectangle and C triangle implement different versions of area. Therefore, we cannot implement it in the base class. This is when virtual members become handy.